Hello everyone. In this video, we'll see what is EDA, Exploratory Data Analysis, what are its objectives, and we'll start working on a dataset in Python. So starting it here, Exploratory Data Analysis or EDA is nothing but a technique to analyze and investigate datasets and summarize their main characteristics, often employing data visualization methods. Now, why do you think EDA, that is exploratory data analysis, is necessary? The main purpose of EDA is to help look at data before making any assumptions. It can help identify obvious errors as well as better understand patterns within the data, detect outliers or anomalous events, find interesting relations among the variables. Now let's see how to do this using an example. The data that we are going to use today is NBA player stats data from basketballreference.com website. First, let's read the CSV file here. To read the CSV file, we need to import pandas library. So import pandas as PD and then reading the CSV file and assigning it to a variable ds pd dot read CSV and in quotes. The name of the CSV file we are using is mba.csv. So we write mba.csv in quotes here. Now running this. Now displaying the data frame. df So you can see the data frame here. First, let us look at the data set here. The header contains several acronyms. Here, POS is position, age, TM is team name, G is number of games played, GS is games started, MP is minutes played per game, FG is field goals per game, FGA is field goal attempts per game, FG% is field goal percentage, and so on coming here, FT% is free throw percentage, ORB is offensive rebounds per game, DRB is defensive rebounds per game, TRB is total rebounds per game, AST is assists per game, STL is steals per game, BLK is blocks per game, TOV is turnovers per game, PF is personal fouls per game, PTS is points per game. Now let's learn EDA in Q&A form. We ask questions and work on the code for it. Now, to look at the shape of the data, what we do? We do df dot shape. This gives the number of rows and columns of the data frame. Here we can see 708 rows and 29 columns. So the next one, if we look at the data frame again, we can see it only displays 10 rows, the first 5 and the last 5. If you want to see the entire content here, you can use this pd dot set option display dot max rows. We can set this to size of the data frame, that is df dot shape 0 plus 1, that is the number of rows. We'll run this. And now if you look at the data frame again, you can see all values are displayed here. And if you don't want to have this length data frame, you can revert it back to default by setting the max rows to 10. Similar to the before one, pd.set option, set it to display dot max row to 10, similar to the one which we did here. And now running this. Now we'll look at the data frame again. And now it will list only 10, which are first 5 and the last 5. Now let's have a look at the data type of each of the column of this data frame here. To do this, we need df.t types. So we are going to see that players are objects, position is an object, team name is an object, and the rest are integers or float numbers. Now, to show specific data types and data frame, you could use df.select d type, and by simply writing include equals to number. This is to show all numbers. Running it, you will get all the numbers displayed here. And similarly, you can also replace numbers by objects to show all the objects. We'll just copy this, paste, and we'll replace number by object. Now running this, you can see the objects are displayed here: player, position, and team name. Now let's see conditional selection. We want to show specific rows or columns in dataset which satisfies the particular condition. Let's see highest points scored per game. Highest points scored per game is the column PTS, which is average of points scored by the player, that is total points accumulated by player divided by number of games played. In order to select point from the data frame, we'll use df dot the column name, which is PTS. Running it, and you can see the column is displayed here. This is one way, and the other way you could do is df giving us square brackets and in quotes the column name PTS. Running this. The same PTS column values are displayed here. This is to select a particular column, and to get max value if that of that column, we use max function. We use df dot pts dot max, and here it gives the max value as 36.1. Similarly, if you want to do it for the other format, pts dot max function. Again, we get the same result, 36.1. But here it won't tell you the name of the player. The next question is which player scored the most points per game. So we'll use conditional selection here. We'll write df dot pts equals to df dot pts dot max. Running this, and this will show us the name of the player and the entire row of the player who scored most points per game. You can see James scored most points per game, which is 36.1. Now, if we want to return specific values like the team name, we just simply assign this to a variable and access it. Just to simplify it, we'll assign it to a variable player max points equals to df pf dot pts equals to pf dot pts dot max. Running it. Now it is assigned to this. We are going to use dot to access TM column here. Player max pts dot TM, the column name, and we can see the team name here, HOU. To get the position of the player, you simply need to replace TM with the column name, which is POS. We'll do that. Player max PTS dot POS. We can see the position is PG. Now, to see how many games the player played in a season, we'll write player max PTS dot, the column name is G here. You can see 78 games are played by the player. Now, to know which player or players scored more than 20 points per game, they put the condition inside the column selection. That is df pf dot accessing the column pts giving the condition greater than 20. Here, TF bracket means we want to select the rows containing the given condition, which is df.pts greater than 20. Now running it, we can see the players or rows whose PTS score is greater than 20. Now, to know which player had the highest 3-point field goals per game, we'll use 3P column. We'll simply do df accessing 3P column PP equals to df pp dot max. Running it. So this will return the rows matching the condition of max value in 3P and the player is Stephen. The next question is, which player had highest assists per game? That is AST. We are going to use the same concept here. df will simply replace 3P by AST, that is the column name. df AST equals to df AST dot max. Now running this, you can see it returns the column, the row, Russell. And now, which player scored the highest in Los Angeles Lakers? We'll use group by function concept here. We'll first group the data by team and select specific team that we want, that is LAL, and assign it to a variable. So creating a variable LAL equals to df dot group by, we'll group by team name. So we'll give the column name here, group by team dot get group and the group name is LAL. Running this. Now let's see what is in LAL here. You can see in team column all the players are from LAL team. You can simply change the group name there to get grouped by different team. Now to see players who scored highest in LAL, you just simply need to do LAL LAL dot TTS equals to LAL dot TTS dot max function. Running this, you get the player here, James, who scored the maximum from the team LAL. The next question is, of the 5 positions, which position scores the most points? To answer this, we first group players by their positions. So we'll group them first. df dot group by position dot pts dot describe. This gives us the descriptive statistics. Running it, we can see that there are more than 5 positions here because there are some hybrid positions, meaning that some players played 2 positions. We can see the count which is low. C and PF is 2, 2, 2. We can see the count is slow. That means very few players played like this. And so we'll remove these first. First, we are going to define a variable called position. And inside, we are going to make a list of 5 positions that we want to be shown, which are center, power forward, small forward, point guard, and shooting guard. So we'll create a variable list positions and center, power forward, small forward, point guard, and shooting guard. Then we are going to define a variable called POS. OS equals to df dot is in positions. And then finally we'll print POS. What this essentially does is it will remove all of the irrelevant position out, and it will display only a subset of data which contains the positions that we want in the list. As we have only 5 positions here, it will display only 5 that are in the list. Now just running this, you can see 700 rows here. Initially we had 708 rows. That means 8 rows are missing. And these 8 rows are the combination of these positions. Now let's look at the descriptive part again. POS dot group by POS, sorry, POS dot TTS dot describe. Running it, we see 5 positions here and we get the count, mean, standard deviation, maximum value, minimum value, and also the quantile values. From mean, we can see that the most points are scored by the center position, but still they are roughly the same. Okay, so this is this for this video. In the next video, we'll visualize the data set, we'll make some histograms, heat maps, scatter plots, and more. Bye.